This is Chapter 7, Lecture number 1. We're dealing now with what we call an ionic compound. Everything we've been doing up to this point, valence electrons, charges, they're all going to apply in this chapter. So we start off with a question. When we combine sodium and chlorine, we form sodium chloride. The formula for sodium chloride is NaCl. Well, why is it NaCl and not NaCl2 or Na2Cl or any other possibility? We're going to see that sodium chloride has a very high melting point, and it can conduct electricity when it's dissolved in water, but not as a solid. So we're going to start looking at the characteristics of compounds. So Mendeleev arranged the periodic table based on similar properties. Scientists then learned that these properties are based on valence electrons. Valence electrons are the electrons in the highest principal energy level, which we know of as shells. We show these through electron dot diagrams, which are called Lewis structures, and all of this should make sense. Lithium in group 1 has 1 valence electron. Neon in group 18 has 8 valence electrons. Noble gases are unreactive in chemical reactions. So noble gases won't react with other elements. In 1916, Gilbert Lewis proposed the octet rule, and that the reason they don't react is because they already have a certain number of electrons in their outer shell. Every atom tends to want to achieve the configuration of a noble gas. Each noble gas has 8 valence electrons, except for helium, which only has 2. In order to achieve this, atoms of the metals, or atoms of the metal elements, tend to lose their valence electrons, leaving a complete octet in the level below. We know aluminum is 283. The aluminum ion is 28. An atom's loss of valence electrons produces a cation or a positive charged ion. So sodium will lose its 1 valence electron, producing a sodium ion with a charge of +1. Magnesium will lose its 2 valence electrons, producing a magnesium ion with a charge of +2. Atoms of the nonmetallic elements tend to gain electrons, forming a complete octet in their outer level. If you gain valence electrons, you produce an anion, or a negative charged ion. Chlorine has 7 valence electrons. It will gain 1 electron to form a chlorine ion with a charge of -1. Oxygen has 6 valence electrons. It will gain 2 electrons to form an ion with a charge of -2. In order for a metal to lose electrons and a nonmetal to gain electrons, they have to bond. A bond is a force that holds 2 atoms together. When bonds are broken, energy is absorbed in order to break the bond. If you want to break a piece of wood, you have to supply energy to it to break it. When bonds are formed, energy is released. When you release energy, you become more stable. The noble gases are chemically unreactive. They are inert, which means they don't react. For an atom to be stable, it wants to be like a noble gas. Then, noble gases have 8 valence electrons, except for helium, which only has 2. Therefore, 8 valence electrons signify stability. So how do atoms reach this stability? And the answer is they bond. The first bond we're going to look at is an ionic bond. An ionic bond forms when opposite charged ions, anions and cations, attract each other. This is called an electrostatic force. Since it's opposite charged ions that are attracted and held together, it is called an ionic bond. So let's look at the formation of an ionic bond. We will use sodium chloride. I'm going to use just the symbol of Na for the nucleus. Sodium is atomic number 11, so we have 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the third shell. So sodium, 281. Since it has 1 valence electron, we give it 1 dot. Chlorine is atomic number 17. So 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the third shell. I'm going to draw the lone electron over there, just to make it easier to see what happens next. Chlorine is 287, so the symbol of chlorine with 7 dots. Now, in order for stability to be reached, the easiest way to happen is for sodium to give its 1 electron to chlorine. But in doing that, it will no longer be a sodium atom. It loses an electron. It loses the dot, and so we end up with a sodium ion. Chlorine that took the electron will now be a chlorine ion with a minus charge, and then we put the chlorine in a bracket just for convention. But we see we have a positive charged sodium ion, a negative charged chloride ion, and it's the attraction of the opposite charges that form the bond. This is a bond of ions, or an ionic bond. Ionic bonds form when electrons are transferred from one atom to another. If we use table S and we looked at electronegativity, an ionic bond forms when the electronegativity difference between the 2 atoms is more than 1.7. But we're going to generally just say an ionic bond forms when a metal bonds with a non-metal. Ionic bonds have certain properties. Think salt. They have crystalline solids. They have high melting points, and they conduct electricity when melted or dissolved in water. So I think that's going to be it for today. And we will continue this in class. So have a great day.